Experts in the crowd? The theologian waves his hand. Ambulo means walk. Cetus means, and natans means swim. This is the walking, swimming whale. How do you know it's a whale? Well, if you're an expert, unlike me, you recognize features, perhaps not from this simple diagram, that are clearly whale-like in this thing, but it has legs, feet. It can walk. It was probably one of those half in the water, half out of the water kinds of things. Ambulocetus natans. By the way, situated at a time in the fossil record that clearly suggests that it was one of those species that then gave rise to other species that gave rise to others that gave us whales, the things that come up out of the ocean and go and do their whole whale thing. Be careful what you make fun of. Sometimes you look pretty stupid after it's all said and done. Alrighty, so let's see. Perhaps you didn't know that all of the tetrapods on this planet, and all of you are tetrapods, no insult intended, organisms with 4 limbs, tetrapods. So it was long thought, it seems kind of obvious, that fish gave rise to tetrapods. Right, a walking fish, that's more ridiculous than a walking whale. At least I've seen a walrus, which does look sort of like a walking whale now, doesn't it? How do you find a walking fish? Well, first of all, you should try to figure out when you think the walking fish might have been around. In the Devonian, perhaps. And that's a little bit of jargon I barely understand, but that's not important. And then you would be nice if you knew where there were some Devonian rocks you could go dig around in, maybe say in Greenland. And then you would go look for, I don't know, walking fish, fishopods. Species that look like fish and look like tetrapods. Because if tetrapods came from fish, something in there should look kind of like both, right? There it is. It's called Tiktaalik. It was described just 5 years ago. And the folks who described it work at the the Field Museum in Chicago. So Neil Shubin sort of headed that team, wrote this great book that I'll recommend later if people want to read more, called Your Inner Fish, har har. If you want to get really close to Tiktaalik, go to the Field Museum. You can see all sorts of cool stuff there, including Tiktaalik. This is, they call it now, the fishopod. It's part fish, part tetrapod. Its fins are turning into fingers. It's the exact kind of thing that people tend to mean when they say, where are those transitional fossils? Where are the things that sort of link these different lineages together? Now, why are we mentioning this? Well, I would simply suggest to you that common descent explains the presence of weird things in the deep past that look like, half fish and half tetrapod, or whales with legs, or dinosaurs with feathers. We expect that sort of thing, and common ancestry gives you an explanation. It doesn't say, that's weird, a walking whale? Never heard of such a thing. All right. I mentioned feathers, dinosaurs. Those are really cool. Winged, feathered dinosaurs, all sorts of cool stuff that people are digging up, mostly in China, I think, is where they're finding a lot of those fossils. Now, guys, let me tell you an important point that I want to make about the fossil record, which isn't just that I'm not an expert on it, because you could probably already tell that. The point is not that the fossil record is complete. Critics of evolution often say the fossil record is incomplete. They're absolutely right. Surprisingly enough, every organism that has ever lived has not been preserved in rock on this planet. Not even a reasonable subset of them. No, the point is that, oh, by the way, nor do you look at the fossil record even in stylized form, like that first slide I showed you of the fossil record, and then read evolution off that slide. No, it doesn't work that way. Instead, the fossil record shows us phenomena, really kind of strange phenomena. Walking whales, feathered dinosaurs. It shows us that, and common descent provides an explanation. Organisms have changed through time. You don't get whales from cow-like things without going through some intermediate that looks kind of like both. It's hard to picture any other way to get there. Evolution provides an explanation. Are we missing some, by the way, are we missing transitional fossils? The missing link? Well, let me just point out an obvious fact, that if I show you 2 organisms that look like they're kind of different, and I suggest they came from a common ancestor, and you say, show me the transition, and I find it, I just created 2 more places where you can say, show me the transition, and this is a stupid game to play. Right? So critics of evolution have to do a little bit better than say, where are all the transitional fossils? Well, we found some pretty cool ones. How many do you need? All right. That question was not addressed to anyone in this room. This is the evidence that Darwin found most convincing. He lived in a different era. He didn't have a whole lot of fossils, and he didn't even know what DNA was. What he noticed as he sailed around the world was that organisms and their fossils are distributed in very interesting ways on this planet. The study of that is called biogeography. That means simply the geographical distribution of organisms and their fossils. And there's something kind of remarkable about it. And I hope you won't be offended if I say alighting from a boat in Turkey hasn't provided any explanatory leverage at all in figuring out why animals are distributed the way they are on the planet. I didn't say that there wasn't a boat in Turkey. I'm saying animals coming 2 by 2 out of that boat don't help us. We can't figure out what's going on. For example, actually, how many of you have been to Australia? I know some of the chemists have. You've done the bike trip to Australia. How many of you have been to Australia? I knew Elizabeth had to raise her hand. Yeah, all right. So marsupials. Oh, no, I'm dead. Oh, there we go. Marsupials in Australia. You know, there are actually 2 kinds of mammals. There are marsupials, the ones that give birth to a little tiny embryo that crawls into a pouch and grows up in a pouch. I mean, to this day, when I say that, it sounds wrong. What? Really? Then there's normal mammals whose embryos grow inside a hidden place and attach like parasites to the side of the place and grow up there. Those are the placentals. Right? You were all parasites once. You went onto the inside of your mother. Again, don't be offended. You all did it, so it's okay. Placental mammals, marsupials. It turns out that in Australia, all of the native mammals, emphasis on native, all the mammals that are from Australia are marsupials. There are marsupials in Michigan. You see them splattered all over the road every now and then. Sometimes you see them right before you splatter them all over the road. They're really kind of weird and creepy, right? They got that little pointed face, little glowing eyes, little babies clinging to them. So it's not true that marsupials are only in Australia. There's something striking about the fact that all of the native mammals in Australia are marsupials. No, there's an exception. Would anyone like to guess the placental mammals that are, in fact, native to Australia? Bats. Because they can fly. Well, that's what we think. I guess you could offer another explanation. I haven't heard any good ones. But all of the native marsupials in Australia, all of the native mammals in Australia are marsupials. Common ancestry, combined with what we know about geology, plate movement, has a ready explanation for this. So the animals diversified there. There was native species that diversified, and they were all marsupials. They were copying marsupialism from their ancestors, who were specific to that place. A few cheaters flew in, flying mammals, who'd have thought? And so they got to establish their placental reign in Australia until some other cheaters who could do this arrived, and then now there's all sorts of mammals in Australia that don't get along so well with the marsupials. And some of the coolest species anywhere are extinct marsupials in Australia. Another topic, but there are marsupial wolves, marsupial rabbits. They're not really wolves, they're not really rabbits. They sure look like a wolf, but it's a marsupial, completely different animal. All right, so you'd all know about the Galapagos finches, and if you don't, this book won the Pulitzer Prize, The Beak of the Finch. Check it out, it's really cool. Everyone thinks Darwin figured out evolution by looking at finches. No, not so much, but the finches are an interesting story. All these birds in this archipelago, this group of islands that's out there in the middle of the ocean, but it's kind of close to South America. All the birds there are finches. Birds that can peck, birds that do this, birds that do that. All these interesting niches are filled by birds that everyone thought were something different until some expert looked at them carefully and went, dude, they're all finches. What? What's up with that? By the way, the answer, God likes finches in the Galapagos, is perfectly good, but it doesn't provide the kind of explanation we're looking for. Finches somehow colonized the Galapagos, own the place, and they've been diversifying ever since and filling these interesting roles in the ecosystem with finches. This is one of my favorites. Does anyone know how many species of fruit fly are native to Hawaii? I'm pretty sure it's 6,000. Drosophilids, so Drosophila, you've heard of them. They fly around my house every now and then when the bananas hang around for too long. So, do you know how many species of ants are native to Hawaii? 0. All right. It's pretty easy to explain that from common ancestry, right? Somehow some fruit flies got there, on the bananas, I guess, I don't know. And then they filled the place up with fruit fly specializations, all sorts of different fruit flies. The ants, well, they missed the boat. They never got there. They're there now, by the way, I'm sure. And yeah, so biogeography. I didn't even mention now the fossils. When you look at fossils in Australia, there's fossil marsupials there that are extinct. There aren't those weird fossil marsupials that are extinct in Michigan. They're all in the same place. Darwin was really impressed by this, and I think what he was doing was comparing it to predictions that the science of his time would have made. The science of his time, a global flood that covered the earth, then the waters receded, and animals then migrated to their positions. It doesn't work. Comparative anatomy and common ancestry, or comparative anatomy and embryology is what your outline says. So it turns out that if you compare anatomical structures in various organisms, you start to realize that animals that seem quite different to you, like, say, bats and people, have really interesting things in common. Structural sort of design features that are held in common. Not only do they look similar, they even develop the same way. Now, that requires an explanation. Well, that's interesting. Why do humans and bats look the same in some of their structural characteristics, and why do they develop the same? So here are some examples, and this is the classic example of comparative anatomy providing data that evolution strives to explain. This is a bird's forelimb. This is a bat's forelimb. This is an interesting comparison because you're like, well, of course they're the same. They both fly. Wait a second. That's a mammal. This is a bird. Not shown on this slide is, say, a human forelimb or a whale forelimb. Or, come on, throw out your favorites. Raccoon forelimb, kangaroo forelimbs would work pretty well up here. Any favorite tetrapod species in the crowd? All right. There's something interesting about these forelimbs. Here's the bird, humerus, radius and ulna, carpals, and then little claw things sticking out. Here's the bat, humerus, ulna and radius. There's the carpals and little things sticking out. These things are kind of fingers. Anyone ever seen a bat's wings backlit? Looks like a rat with really long fingers. And this is a bird. Do you guys know your human anatomy? Humerus, ulna and radius, carpals. So in this book, Your Inner Fish, that I showed you before, Neil Shubin says, you know what? It's easy to describe any limb on the planet. It has to be a real limb, so fish fins don't count. One bone, two bones, little blobs, then digits. One bone, two bones, little blobs, digits. Repeat after me. One bone, two bones, little blobs, digits. Now, why? I can think of two explanations. Explanation number one, this is the only way to do it. Try it any other way, everything falls apart. Or it doesn't work very well. The bat can't fly, it hurts all the time, I don't know. Obvious possibility number two, this design does work. It works pretty well. I'm, making it happen. And I inherited it along with this bird and this bat and that whale, that raccoon, possum, kangaroo, et cetera, et cetera, et cetera. We inherited this design from a common ancestor and haven't been changing it. By the way, we changed it a little bit. Like these things look different from those things.